our monthly webinar. We're going to wait about another minute to make sure everyone has a chance to sign in, and then we'll get started.
Hey, Bill.
Again, good morning. My name is Bill Hayden, the president of the Northern Virginia Post of the Society of American Military Engineers, and I want to welcome you to our 11 June virtual meeting. This is a second of virtual meetings that we've had. Obviously, with the coronavirus pandemic ongoing, almost all organizations have switched to a virtual format, and that appears to be working just fine. It's doing our best to help contribute to safeguarding all of us until other solutions come about for the medical emergency we find ourselves in. So we're all doing our part. Normally, with the physical meetings that we have with SAME, with the Northern Post, we also obviously host a luncheon, and then there are some additional funds that come in from those luncheons that we use to fund our scholarship programs. With the absence of physical meetings, we didn't have a means to collect any funds for scholarships, and as a result of that, we have made these virtual sessions free, but also offered to attendees the opportunity to make a small donation towards our scholarship effort. For today's session, we have pledges of almost $1,500. So thank you everyone who participated in that. It's making a big difference, and we have many scholarship and STEM activities that we fund as a voluntary organization, as the Nova Post, and we do thank you for contributing to that. So you are all of those who contributed today. You are our sponsors. Thank you. Today is a very special session. It's a co-meeting of the Northern Virginia Post and the Joint Engineer Contingency Operations Committee, or Community of Interest, or the JECO committee. That is a committee that I was involved in for several years, and the new committee chair is Mr. Jim Romaz of WSP. Jim, I'm going to turn over to you for some comments about JECO.
Yeah, thank you very much, Bill. I appreciate that. And the JECO community community of interest is very excited to be co-sponsoring this event with the SAME Nova Post, and look forward to the discussion from the panel members as well as those in attendance. I just want to give a little pitch on JECO in case folks aren't aware of us as a community of interest. We are a national level organization, just like all of the other community of interests, with specific focus. And our focus is to facilitate discussion among the military services as well as industry on current joint engineer operations and the issues that need to be addressed for future joint engineer operations. And ultimately, our desired end state is the increased relevancy of SAME within the joint force as well as component engineer communities. We accomplish this through several means that include such things as sponsoring industry speakers at the Joint Engineer Operations course. We sponsor joint and overseas engineering track education center sessions at JETC. This past year, we sponsored or co-sponsored 8 education sessions. We also conduct bi-monthly meetings from the fall through the spring in which we have guest speakers. This past year, we had the USACE Transatlantic Division Commander, the Joint Staff Engineer, as well as 2 Combatant Command Engineers discuss the challenges that they're facing within their respective areas. And our big event is the conduct of a tabletop exercise during SAME JETC. We successfully conducted 4 tabletop exercises from 2016 to 2019. Obviously, we couldn't conduct one this year because of the virtual nature of the event, and we just couldn't adjust from an in-presence tabletop exercise to a virtual event quickly. And there were other concerns. However, for 2021, whether JETC is virtual or in person, we will be having a tabletop exercise. I know that many of the folks here are current JECO members. However, if there's anyone out there that would be interested in joining the JECO community of interest, please do not hesitate to reach out to me, and I will add you to our bi-monthly meeting invites. We currently have over 500 declared members. The reality is we have about 110 active members, and those members are not only located in the United States, but also overseas, a mixture of active duty and industry, but we're always looking for new members with fresh ideas and perspectives. So again, we're very pleased to be co-sponsoring this event with the St. Nova Post, and do look forward to this, to the panel speakers as well as the discussion. So back over to you, Bill.
Thank you, Jim, and Jim's doing a great job as the community of interest lead for the JECO committee, and we look forward to maybe future events as well with the Nova Post. With that, I'm going to switch over to some Nova Post news. This is just some things that are, some of them are kind of obvious. Obviously, our physical events have been canceled for the time being until we can reassemble safely. So in lieu of our physical meetings, we're holding virtual seminars or webinars. Right now we're looking at keeping that mode through at least September of this year. In terms of the post membership and management leadership, the board of directions slate for the handoff is coming up soon. That handoff happens in August of each year, so we've got 2 more months under the current board of direction, and August will be the transfer to the new one. I think everyone's probably tracking already that the national SAME camps for this summer have been canceled. As a result, the Nova Post now plans to sponsor a local STEM camp here in Northern Virginia in lieu of. So the money that we collected for the SAME camps will go to good use, supporting local attendees at a Northern Virginia-based STEM camp. I do want to give a shout out to all of those who were involved in the virtual JETC this year. It was 2 weeks ago. Great success, wonderful event. Yeah, okay, a couple of little IT glitches here and there, but by and large, an amazingly well attended and well engaging event by everyone who took part of it. So hats off to National for taking the chance on doing that and pulling it off. Great event. A couple quick announcements on the future SAME events for Nova Post. On July 9th, we'll be hosting another webinar. This one will be on critical infrastructure asset protection from the Chief Executive Officer of Energy and Natural Resources Security. Looking forward to that session. That should be very interesting. On August 6th, we'll have our webinar where we hand off post leadership for the board of direction. Speaker to be determined for that one. On September 3rd, we're looking to do a resiliency event. Planning is still underway for that one. And on October 8th, we're crossing fingers that we may be able to resume doing physical events. That is normally our business-to-business conference month. And we will look forward to potentially having a physical and or virtual event, maybe in combination, for those who are able to attend physically. They will have it at the Waterford, and if not, those can attend virtually. More to follow as we work through the planning details for that. Okay, now let me switch to today's event, which is the Military Engineering Panel. So the concept for this came months and months ago, working with partially through our JECO contacts and through some other events that we were planning. The idea of having an event where we have speakers from the military explain to us or update us on the roles and functions of military engineers. This is not a session about business opportunities. We get plenty of that through SAME events. This is one more about what the engineers in uniform do. And we were very, very fortunate today to have a number of highly very senior, highly qualified, very experienced engineers from 6 services, and those are Colonel Jason Kelly from the Army. He is the director of the Office of the Chief of Engineers. We got Colonel retired Rob Kauser, who's the branch head of the Engineer and EOD branch of Headquarters Marine Corps. We've got Captain Luke Green, who is the OpNav N 464, or the Facility Investment Branch lead. We've got Colonel Aaron Altweiss, who's the Air Force A4 on the Air Staff in the Pentagon. And we got Captain Pat Dugan from the Coast Guard. He's in the CG-43 office. And finally, Captain Nelson Nix, who's from the Public Health Service. He happens to be with EPA currently, but as I'm sure he'll explain to us, public health service officers serve in a variety of government agencies across our nation. And there's a very large engineer corps associated with that group. So we're looking forward to hearing from all these gentlemen today about engineering and what engineers do. Okay, with that, I'm going to attempt to make sure I can operate the GoToMeeting platform here. And let me turn over this to, I'm going to turn the presentation over to Colonel Jason Kelly. If I can find them on the list here. Here we go. Okay, Jason, you should have that. Let me read something real quick about Jason. Colonel Kelly is our director of the Office of the Chief of Engineers. He's been there just a little under a year. In that role, he aids the implementation of the Chief of Engineers intent for engineering support both to the Army and to the Joint Force. He's an advisor across the Army staff, the Joint staff, engages with the combatant commands, the Army Service Component Commands, and the Army Engineer School. He oversees engineer force structure, resourcing, manning, training, equipping, deployment, and transformation. He also supports domestic and overseas contingency operations through USACE and the Army Operations Center. Previously, Colonel Kelly has commanded the district in Afghanistan, the Corps District in Afghanistan. He also commanded the Norfolk District, and he's held leadership positions throughout all his career from platoon to brigade level with duty all around the world, including Asia, Middle East, and across the United States. Colonel Kelly is a West Point graduate from 1994. He has a bachelor's degree from West Point, master's degree from Missouri Science Technology, also from Georgia Institute of Technology, and also the National Defense University. War College graduate and several other schools. He's also a PMP on the civilian side. Colonel Kelly, I'll also announce, is on his way. Today is his last day, or tomorrow, I guess, is his last day as the head of OCE. He is getting ready to take command of the South Atlantic Division of the Corps of Engineers. And Jason, thank you very much for joining us today, and we'll look forward to hearing your comments about what engineers do in the Army. Over to you.
Thank you, Bill, for such a warm welcome, and let me thank FA&E for this opportunity. I'm an extremely proud member of the U.S. Army Engineer Regiment and relish this opportunity to share. The totality of my adult professional life has been devoted to the regiment, and there are many in this audience today that could say the same. I do want to, as I start this session, I want to refer all questions. I saw Matt Tyler come up and Ed Chamberlain. So anything that I say that may get a little off kilt, blame them and they'll clean that up for me. They've been doing that for quite some time. So it's good to see those guys come up on the net. Hey, I'll be brief, and this first slide attempts to capture it all in pictures. We are the U.S. Army's Swiss knife. We build, we destroy. We map, we shape the terrain, we dive, and we fight fires. Mobility, counter-mobility, and survivability are our watchwords, while combat engineering, general engineering, and geospatial engineering provide the foundation for all that we do. FAONS, let us try, is our motto. But I like the way we close it out. We will succeed, and that is what we've been doing for the U.S. Army for quite some time.
Kathy, Jason, somebody muted you. We got to fix this. Hang on a second.
There we go. Can you hear me now? There we go.
Yeah, we can. Yeah,
how about
back.
Now? Okay, there we go. Okay. So this slide depicts the Office of the Chief of Engineers. And what we do in OCE, we walk point for General Simonite and the many hats that he wears as the Chief of Engineers. General Simonite is an Army Staff Principal. He's also the Commanding General of the U.S. Army Corps of Engineers, but he's our Chief of Branch. And that's kind of where I want to live. I'm in the lower left of this chart. And as the Chief of Branch, in conjunction with our Commandant, Brigadier General Mark Quander, who operates out of Fort Leonard Wood and who's the architect of the regiment, General Simonite is our 3-star senior representative, and he's active not only in the Department of the Army or on the Army staff, but also in the joint space, which is especially relevant today. And I'll highlight that again later as I try and communicate that we don't fight as a regular Army force. We're a multi-compo organization, and much of the engineer capability resides in the National Guard and Army Reserve. So one of the things I wanted to highlight here is Career Management Field 12, or engineer, is a total force, as I previously stated. I've been in combat multiple times, and I've never fought with a formation of regulars only. And this top slide highlights that reality. Almost half of the Army's engineer capability, all specialties, is in the National Guard and Army Reserve. So my office, what that really means is we're always mindful of what we think the time phase deployment, what the requirements will be at the onset of any conflict for what's in the active component is what we'll have to fight with initially. And we've got to be wise about how we phase subsequent engineer support. So this slide gives you a taste of where the force resides, and as I highlighted, combat general, and I called out geospatial, but you could look at the specialty engineers in our dive detachment, our forward engineer support teams, and our main and our advanced teams, capabilities that could augment field forces and provide a contractual and technical capability. But you can see that we're reliant on both the National Guard and the Army Reserve. I'm sharing this slide in an attempt to depict what we've charged the regiment to do over time. Today's practitioners, in fact, are highlighted on that top bar and where they'll be as this capability or this plan is realized. I'd like to call out the years 2028 and 2035 as the Army transitions to multi-domain operations, the creation of a multi-domain capability. 2028 has been identified as the period that we want to have a multi-domain capable force. And 2035, we want to be ready. Modernization, force structure are major in that realization. And the Army, in the way that we do that through our total Army analysis, there are only a couple cycles left for us to achieve what must be true in 2028. I'll call out the M113 replacement. Many of the men and women on today's call rode and M113 personnel carriers. I did as a second lieutenant. I just completed my 26th year a few weeks ago. We still don't have a replacement. It's an ongoing discussion in the Pentagon because as we think about being able to be in position to provide mobility for the fighting force, you got to be able to keep up. The Joint Assault Bridge is another capability that's in development, and we've got some work to do. I'll highlight, again, some of the other modernization efforts that are underway, but I'd ask you to think about 2028 and 2035 and efforts underway now to ensure that all that I highlighted, the engineer force is responsible, mobility, survivability, counter-mobility, our dive capability, our geospatial capability, demands that we keep pace, that we continue to evolve so that we're relevant on the battlefield. This last slide is my ode to Lieutenant General Semonite as he prepares to depart. This dirty dozen is the way that he's mapped out what we work on. It's how we're going to achieve what we desire to be in 2028 and 2035, that ready force that we want to field in 2035. This is just a list of some of the modernization and other efforts that are underway. What it really gets at is our desire to develop leaders, warriors that are going to be at the table offering solutions to the maneuver commanders. Really excited about what's underway. I will tell you, in this era of declining resources, money is tight. Every advancement that we've made, fragile. Many of the decisions that we thought were done, we'd be well on our way in fielding equipment, all are being reviewed. So this slide, I want to call out the red there in our modernization plan. In order for us to be what the Army needs its engineers to be in 2028, we've got to do better with modernization. We have not been as successful there, so it's a place, as I prepare to depart the Office of the Chief of Engineers, my successor, Colonel Jeff Van Epps, I will pass the baton to him and ask him to be vocal in the Pentagon as we talk with those that are managing our portfolio in terms of equipment, those that are managing our portfolio in terms of manning, to make sure that we don't lose sight of all that the Engineer Regiment has done to date. If we're going to continue to be what I'm confident we need to be, and again, I'll call out 2028 and 2035, the modernization and readiness of the Engineer Regiment is a place that we've got to do better. I'm just about out of time, so I think I'll leave it there. So much more than I could talk about. I did not go deep into the actual functions in terms of specificity. Suffice to say, though, that the Engineer Regiment, we do a little bit of everything. And I did not speak to the matriculation of this group of engineers that comprise the regiment also cross over and get into the Army Corps of Engineers, the organization that General Semonite leads, that 30,000 plus that get after the nation's civil works, military construction, environmental, navigation, etc. mission. Same group of people. So much underway in terms of talent management to prep for tomorrow and make sure that we have leaders capable of executing this very important mission, your Army's Swiss Knight. Bill, I'll hold there if there's any time for questions. If not, certainly we'll stand by as long as I can. I've got till about 12:30 and I've got to move to another session. But thank you all for your time, and hopefully you found that beneficial. A little bit about what your Army engineers do for the force. Over.
Thank you, Colonel Kelly. That's a great overview of the current state of the regiment and the different missions and structure, and really appreciate that. What we're going to do is just take Army-specific questions for about 2 minutes, 2 or 3 minutes, and then we're going to move on to the Marine Corps. Any questions for Colonel Kelly about the Army presentation? And you can ask questions either by unmuting your mic or by putting it into the chat box. We'll take either way. And speaking of which, if you want to queue up questions along the way, just put them in the chat box and we'll address them at the end, because we're going to do a general Q&A session at the end as well. Okay, Colonel Kelly, sounds like no specific Army questions. At this point, I'm also going to just an admin note, please, folks, if you have a camera on your system, and if you look at the bottom of your screen, there should be 4 little icons: mic, camera, screen, and leave. If you would please turn off your cameras if you're not a panel member, I'd appreciate that. That will reduce the number of active cameras that are up on the top screen. Also, you can reduce your view by clicking the options at the top of the screen to limit your view to the active cameras. That was the intent, was that you would only see the folks who are talking. Okay. So the next speaker is Colonel Retired Rob Cowser. Let me tell you a little bit about Mr. Cowser. I worked with Mr. Cowser a great deal in the past in my former life. Rob is currently the Deputy Director of the Engineer and Explosive Ordnance Disposal Advocacy Branch in the Logistics Plans, Policies, and Strategic Mobility Division, Installations and Logistics Department of Headquarters, United States Marine Corps. He retired as a colonel in 2017 and has been with that organization since. He actually started with the Air Force, graduated from the Air Force Academy in 1987, went to the Basic Engineer course in '88, and has served in a wide variety of operational commands, operations, combat engineer, logistics assignments throughout his career in the Marine Corps, both on the East to West Coast and in Okinawa. He's also deployed several times, Task Force Tarawa engineer, 2nd Med, as part of the Operations Officer Economic Division Strategic Effects Directorate in Multinational Force Iraq, MNFI, as part of Iraqi Freedom, and then also some missions in Operation Enduring Freedom in Afghanistan. Other sorts of assignments that Rob has had: Engineer Advocacy Branch Head in the Headquarters Marine Corps, Strategic Division Chief in the J4 Logistics Directorate. He also served as the Commandant of the Marine Corps Fellow, serving with business executives for national security in Washington, D.C. We're very pleased to have Mr. Cowser speak to us today about the Marine Corps. I'm going to take over presentation, and Rob, I'll run the slides for you as you requested. Let me just take over this, and please let me know when you can see the Marine Corps slides. There we go. So Rob, over to you.
All right, thanks, Bill. Welcome to everybody. Good afternoon. Again, as Bill said, I'm currently at Headquarters Marine Corps Installation and Logistics. Unlike the Army, while we have Marine Corps generals that were engineers, we don't specifically have a Marine Corps general officer as an engineer that sits in the 3-star billet within DCINL. But he serves as our advocate for the Marine Corps. My branch, Engineers and AUD branch, serves as the advisor. We don't actually control everything, but we're the advisor for anything that has to do with manning, training, and equipping the engineer forces in the Marine Corps. I've done that for the last couple of years. Basically returned to the job as a civilian. I couldn't get away from it. Love it every day. Next slide. What I plan to cover briefly, again, engineers in the MACTAF, Marine Air Ground Task Force, for those of you not familiar with the MACTAF, a quick snapshot of the mission statements for each of the engineer units, a visual depiction of what we do, and then lastly, forgetting everything that I will go over, the Marine Corps Force Design, which will basically change the way we operate in the future. Next slide. Okay, engineers in the MAGTF. So Marine Air Ground Task Force is built, the Marines engineers are organized in different units across the MAGTF, which is comprised of the command element, ground combat, aviation, and logistics combat elements. Ground combat element is focused around Marine Corps Division, aviation combat element focused around Marine Aircraft Wing, and the logistics combat element is focused around a Marine Logistics Group. Within each of those elements, as you see depicted on the organizational slide, under the division, we've got combat engineer battalions. Under the ACE, we've got Marine Wing Support Squadrons, and under the LCE, we've got engineer support battalions. As depicted, we basically have organized in groups of threes, obviously. On the division side of the house, 2 active duty CEBs. We used to have a 3rd Combat Engineer Battalion, but that was disbanded, organized into a smaller combat assault company. On the aviation side of the house, we basically have 3 MWSSs per wing. And then on the LCE side of the house, we have an engineer support battalion that supports each of the MLGs underneath the specific MEF. So that encompasses over 19 specialties, not to include the EOD, MOSs, over 12,000 active duty, 3,000 in the reserves. So obviously the bulk of our engineers are in active forces, and the bulk of those engineers predominantly are embedded within the logistics combat element. Next slide. Okay, quick overview of the mission statements for each of the major engineer units. Common Engineer Battalion, again, focused on supporting the division with the traditional mobility, counter-mobility, survivability missions. Engineer Support Battalion, primarily focused on general engineering support. This also includes the support for the entire MEF, utilities, bulk fuel, bulk water, and EOD predominantly embedded in the ESBs. And the Marine Wing Support Squadrons provide aviation ground support to the wing. So their engineer services provided there, primarily focused around FARPs and FOBs to support Marine aircraft groups. That's why there's 3 per wing, and then that will be how we continue in the future for the most part. As we get into the next slide, provide you some visual depictions, cover down on what we do. Okay, combat engineering, generally in the Marine Corps, you've got combat engineering and general engineering. That's kind of how we break out our community. Although each of the elements can do what every other element does. It's just a matter of what the focus of training is at that particular point in time. But all the engineers in the Marine Corps get trained the same way. They just focus on specifics based on which element of the MAGTF they go to. Combat engineering, again, mobility, counter-mobility, survivability, engineer reconnaissance. You see in the picture, we've got Marine in Darwin conducting a sweep. We've got Marines working on underground field fortifications, route clearance, counter ID missions. You see a depiction of ADR, expeditionary ADR at an outlying field in Camp Lejeune. You've got combat roads. The picture depicting there is a artillery firing area in Norway. Combat road supporting that one. That was a joint effort between Combat Engineer Battalion, and an engineer support battalion out of the East Coast. And then lastly, mechanized breaching, amphibious breaching, which traditionally has been our bread and butter, particularly for the division units. And I'll get more to that as we cover down in force design. Next slide. General engineering. Again, predominantly, this is where we do our construction, vertical, horizontal construction. We'll see a picture depicting there. Marines working with Philippine counterparts, putting up a roof truss for an elementary school. Heavy equipment operations, non-standard bridging. You've got deployment of a tactical water purification system, lower middle, and hose reel system for the bulk fuel companies out of the ESBs, and then an example of FARP operations, again, at an outlying field in North Carolina during a training exercise. Next slide. Okay, force design. I'm not sure how many of you have kept up with the Marine Corps' force design effort over the last almost a year, it seems, at this point. The Commandant of the Marine Corps put out his guidance to the force. Force design is his #1 priority. It's a 4-phased effort. We've completed phase 1 and 2, which was problem framing and objective force design. We'll now enter phase 3, experimentation. That'll conclude roughly end of fiscal year 23, and then we'll move into implementation. The focus of that effort in the implementation stage will be creating what we're now deeming a Marine Littoral Regiment formation as the first step. Focus of effort will be at 3MEF in the Pacific. This organization, and again, I won't provide a lot of details on it, it's still being developed, but it basically combines elements of all 3 the traditional elements of the MAGTF into one unit, which will be focused on distributed operations to fight a peer competitor. The assumption is 99% of the time we'll be in the competition phase. If we're doing that right, only 1% of the time we'll ever be in conflict. But some significant points that come out of it. Traditionally, we've focused on a 2 Marine Expeditionary Brigade joint forcible entry operation, a construct that is no longer the case. We're not saying joint forcible entry operations won't take place, but it won't be with the construct of a 2 MEB JFAO. They'll redesign the infantry battalion in the Marine Corps. It'll be smaller, lighter, more nimble. MEWs will be redesigned, and then particularly of importance to us from an engineer perspective, divestment of tanks. So armor, the tank mission will go away, which received a lot of pushback because it's traditionally a strong community, but in the future the use of tanks leads to a long land campaign, and that's not what the Marine Corps is designing itself to do. And then obviously in turn with that, we don't need bridges. So the bridge companies go away, at least the traditional legacy bridging equipment that the Marine Corps has held on to for multiple years is going away. So the Marine Corps, again, is designing for a naval expeditionary warfare force to fight a peer competitor. Distributed ops, manned, unmanned, autonomous systems, lighter, smaller, more maneuverable. So the engineer community is at a transformation point in its history where we have to figure out how the community can best support this redesign effort. Expeditionary air advanced bases will be the focus of much of the work. So it'll be smaller units distributed across multiple locations that won't have the traditional log trains that support them. It'll be based on stern landing vessels, light amphibious ships, operational support vessels to bring in logistics and heavy assets. So basically, during the competition phase, while there'll be a lot of engineering work, after that, you're pretty much on your own. until you can get resupplied. So the effort is with the smaller units, that'll transform a lot of what we do in the future. So one of the additional things we're looking at is redesigning the military occupational specialties. So the traditional heavy equipment operator might be one Marine, and you have a heavy equipment repairman as a separate Marine. Or why have two Marines when you can have one Marine operate the piece of gear and fix it? And this pretty much goes along the lines for multiple other MOSs, whether it's a electrician, electrical repairman, or if it's a bulk fuel Marine and a bulk water Marine. Why do we need two MOSs when we can have one guy do both? Added to the fact that produces a smaller footprint on whatever EAB site that they're going to be planted on, so they'll be self-sufficient and they won't rely on multiple Marines, and they won't rely on large legacy pieces of equipment anymore in the future. So if you can produce water off the back of a truck and at the same time produce the power you're required for your small unit, then you don't need to bring in large ROPUs or run any reverse osmosis operations off the beach, because that'll produce too much of a signature and that'll bog you down. The intent is to shoot, move, communicate quickly, which leads into the survivability aspect of you're not going to be digging multiple field fortifications for survivability, because once your firing battery shoots, before its position is given away and the enemy can target, then you're off to a new location that's already been pre-staged and then pre-set up. So a lot of brain power will go into the next evolution of how we design the Marine Corps engineers, and how we organize, how we train, and how we're equipping the force, with the understanding that there's an incredible amount of engineering effort that will be required. It'll just have to be done in a different way. So with that concludes my my brief. Happy to take any questions.
Thank you, Rob. It's a great overview of the Marine Corps. A lot of changes with the moving out of the heavier elements. Very interesting changes. Lots of discussion on that online in different forms. So I'm sure this was of great interest to our audience. Any questions from the audience for Mr. Kauser from the Marine Corps? Okay, hearing none. Thank you, Rob. But we're going to switch now to the Navy, and let me start with a review of our speaker, Captain Luke Green, who's the Facility Investments Branch Head at OpNav N464. He'll explain to us what that is. He comes from Annapolis, Maryland, probably a good place to come from if you're in the Navy. 1998 graduate of the Naval Academy at Annapolis, and has a master's degree from the University of Maryland in engineering. Captain Green actually started his career as a Marine in 1991, and following a tour with the Marine Attack Squadron 211, he went to the Naval Prep School, and then following graduation served the float, and then transferred in 2002 to the Civil Engineer Corps. As a CB, he has served as a company commander for NMCB-1, an ops officer with the Amphib Construction Battalion 1, and the commanding officer of the NMCB Battalion 133. He also served as a planner with Public Works Branch, Marine Corps Base Quantico, a construction manager with NAVFAC Washington, several other important jobs overseas to include Europe, Africa, Southwest Asia, NAVFAC, and NAVUR. NAVAF as a public works officer. He's been in the current job since 2019. He's a qualified combat warfare specialist, CB combat warfare specialist, and special and surface warfare officer. He has a PE license from Virginia, a public works level 3, contracting level 3, and he's a member of the Defense Acquisition Corps. He's also a member of the Society of American Military Engineers. Luke, over to you, and then let me make you a presenter.
All right, thank you, Bill, for the introduction. Did that just create a lot of static for everyone else? I'm getting a lot of static feedback right now. That's much better. All right. Okay, so I'm going to apologize for the static and the feedback. I don't know if everybody else is getting that, or is that just me? Okay, all right, so I'll go ahead and jump into the brief. Thanks, Bill, for the introduction, and it's appropriate that you have the Marine Corps and the Navy tagged right next to each other. Our engineers work closely together all over the world all the time. As we talked about earlier in the panel, certainly we're all operating in this corona world environment. So I'll apologize up front if the dogs start going crazy in the background, if they're running through the screen or anything like that that we're all dealing with. I'm going to go ahead and pull up this presentation. All right. This is, I'll go through and talk about the Naval Construction Force, but before I start that, I'll just say that the Navy's got 71 installations around the world, and our Civil Engineer Corps officers and our Seabees are around the world working at those locations. This brief's going to go focus a little bit more on what our naval construction groups, what we call the Naval Construction Force, are doing around the world. All right, so this is the organization. I'll break down some of this alphabet soup for you and just talk through real quick how we're organized. The Naval Construction Forces fall under the Navy Expeditionary Combat Command, which also houses EOD, Coastal Riverine Squadrons, and other expeditionary forces. Broken out on the West Coast and the East Coast, you see on the left-hand side there, NACC PAC, Naval Construction Group 1. And on both sides were shown there active components in blue and reserve components in white. The main unit of action within the NCF is the Naval Mobile Construction Battalions. We have 6 active mobile construction battalions. They range, manned at about 700 people and carry the full gambit of construction from expeditionary, rough construction, horizontal construction, all the way through finished construction that's code compliant. Underwater construction teams, again, they're Seabees, they do construction, their work environment is in the water. And then the CBMUs, construction battalion mobile units, or maintenance units rather, one on the East Coast, one on the West Coast, and they tend to do more camp maintenance type functions and not as much, those units are not deploying units, not standard deploying units like the mobile construction battalions are. The other unit you see there under the Naval Construction Group, so the Naval Construction Groups are focused on man, train, and equip, and the Naval Construction Regiments are nested underneath the construction groups. They're deployable C2 mode. All right, so this is the force laydown. This is as of March, but 6 active battalions. They are on a 6 and 12 rotation cycle, so 6 months deployed, 12 months back at home port, going through their training cycle. On this map, you see in orange is the East Coast battalions. When they deploy, they take the headquarters element to Rota, Spain, and then deploy as you see distributed there around the world. The ones in red are the West Coast battalions. When they deploy, take the headquarters to Okinawa, and then deploy around the Pacific doing various types of work. We'll talk about that in a second. The UCTs also you see they're deployed. They'll send out a construction dive deck and attach them to the deployed mobile construction battalion. So you get a pretty cohesive team there with a little bit extra capability with the underwater construction side of things. If I had to break this slide down into the most important message, I'd say it's all about posture and presence. And you see we're posturing around the world in strategic locations to support delivery of logistics. In a great power competition,
environment, I would say focus on the Pacific and look at some of those smaller locations where we are. And this was alluded to in the Marine Corps brief. We're focused on EABO. We're focused on littoral combat operation or littoral operations in a contested environment. We're really looking at how we deliver logistics and move around that theater. One of the buzzwords we've used a lot is places, not bases, right? So a much lighter, more dynamic footprint than I think the older mindset of, or what historical mindset of big bases and big logistics nodes. So transitioning away from that. The other thing I would highlight here is you look around all these different locations, the headquarters of that mobile construction battalion will go deploy, but all those little detachments that you see around the world are task tailored. So we'll look at the specific mission set there, and we will pull from within the battalion the right skill sets and send just the right people. And so I'll talk a little bit about Ukraine there. When I was with NMCB 133, deployed twice to Rota, Spain, and had deaths both times out in Ukraine. And this is just an example of the type of work they were doing. Very near the Crimean Peninsula, so as you can imagine, kind of a hot spot. And they were doing exercise-related construction of a couple of pre-engineered buildings. One is a maritime operations center for future exercises and future work between the United States and the Ukrainians, and also building a boat maintenance facility. Perfect example of the type of construction we're trying to do, the relationships we're building, in that posture discussion and presence discussion. And then also one of the big benefits we get here that we're focused on is as we operate in these environments, we're learning those logistics and supply chains. So, some of the more developed areas we operate, it's not as complicated. When you start getting out to some of the smaller islands, specifically in the Pacific, logistics become very, very challenging, especially getting construction material in and out of those small locations. I'm going to jump through some slides here, going through more just the types of work and speaking to what we are doing on a daily basis, a little less word-centric, a little more picture-centric. So we'll start off with HADR. This is a constant constant part of the mission that we do. I think most of you will probably vividly remember the 2004 tsunami in Indonesia, and that was really an eye-opener for us as we jumped in and started doing HADR in that area and had a lot of lessons learned about interoperability and having relationships established in place already before we have to show up and do that type of work. But again, this is a big piece of what we're doing on a daily basis. Here's a couple projects, and again, this is back to that presence and posture. So I'll start off on the left. This is Alayun is a area about 45-minute drive from Camp Lemonnier in Djibouti. And so if you're not familiar with that, it's AFRICOM's main hub on the east coast of Africa. A lot of missions going on there. It's a multi-nodal port, so you've got an airfield and a seaport. But this is just a small village, like I said, near the base. When you look at these pictures, you see in the foreground a bunch of vehicles. This was obviously at the ribbon cutting ceremony. You see the yellowish building, which is the clinic we built. And in the background there, you can see kind of a lot of very small, I'm not even going to call them structures, a lot of lean-tos and things that the folks there were living in. But again, come back to, like I said, posture and presence, and in the world of a great power competition environment. So you see the yellow in the foreground there is a clinic we built. When I vividly remember going out to that site, walking around and asking a question about their white buildings that you see there. Well, that was a school that the Chinese came in and built. A little bit different the way we operate as we try and establish footprints, and we see Chinese presence in a lot of the places where we do operate. They tend to come in, drop some money, throw something together, and leave. We tend to have a little bit better and a more closely integrated with the local community posture and position. We tend to work more closely with them and like to think that we have a longer lasting relationship. On the right-hand side there, you see a project that we're doing out in Rota, Spain. It's a shoreline stabilization project. You see the cliffs in the background. It's hard to tell from that, and especially if you could pan the camera out to the right, you would see family housing units there in Spain, and they've actually lost a significant amount of real estate to the sea. They've lost several housing units, which were vacated prior to them literally falling off the cliff. So anyway, it's just an example of the heavy horizontal type work that Seabees are capable of doing, coming in and building this massive, about a kilometer long shoreline stabilization. Hurricane relief. This was from Hurricane Michael, and certainly a vivid reminder as we enter into hurricane season right now. They just had the storm last weekend down in the Gulf Coast. So something we're always postured for and ready to go out and jump into any kind of contingency environment. On the left-hand side there, you see a project which is drilling a water well down in Colombia, and always reaching out, with the combatant commanders and looking for opportunities to do this type of work. My experience, this is in Colombia, but that's been a significant relationship builder around the world, is the ability to come in and do wells. I've seen Seabees doing that in the Pacific, Africa, all over the world. On the right-hand side there, we see a bridging exercise. I think Rob talked about how the Marine Corps is looking at getting rid of their bridging capability. Navy retains some bridging capability. And then you also see on the bottom right there, UCT divers. Again, they do in-water assessments of ports, of seaports, and do waterfront construction, underwater construction. I think that exercise specifically was up in Norway, so you can imagine the nice warm water that those guys are diving in wintertime exercise in Norway. Again, coming back to just the things that we're doing, on the right-hand side there, you see a schoolhouse construction, right? So CMU construction, locally procured materials. It's the bigger part of this is building a relationship with the locals. A lot of times we do these hand in hand with the host nation military engineers, certainly in close coordination with the host nation, as much as possible using locally procured materials. And again, there's a relationship establishment, but also we are out there learning those logistics and supply chains. Makes a huge difference for our ability to ramp up as we work through the spectrum of conflict, and we reduce our cycle time to be able to get out into a location and execute construction. We've been there before. We already know the environment. We already know the logistics and supply chains. We'll talk a little bit about some technologies that we've been pursuing. When I was the CEO of NMCB 133, my Commodore told me, hey, I was going to be the additive manufacturing guy. It was kind of a pet project of his, trying to ramp up our technology. So we started buying printers, 3D printers, and without a lot of guidance, which was actually very nice, said, hey, just go play with it, see what you can do. So we started cutting our guys loose and just telling them, hey, start building stuff. I know the Marine Corps is also working closely with this and developing some policy as far as where they could and couldn't use 3D printed pieces, right? So as certainly some safety concerns as you look at using it on vehicles, et cetera. We started doing this, and I'll tell you, I don't know for sure the demographics of everybody on this call, but I'm going to guess there's probably a lot of older engineers, maybe folks who spent time in uniform. Every time I had an 06 or above come to my battalion and we'd walk them through and show them what was going on, they were absolutely intrigued. I was always entertained because I would have my youngest troops who were doing this in middle and high school. And so I had guys who were just jumping on the CAD machines and printing out parts like crazy. And people were just blown away because they were so proficient with no training, no formal programs offered by the Navy, and these guys knew exactly what they were doing. So I highlight that as, we end up talking a lot about generational differences, and this younger generation, in my opinion, was bringing some real talented skill sets to the table, especially in areas like this with additive manufacturing. You see here, these are some exercises we did in conjunction with the Marine Corps, bridging, and I'm sure everybody here knows some of the capabilities that we bring with 3D manufacturing. Another technology that we're trying to employ specifically with regard to airfield damage repair is unmanned aerial systems. Obviously, you guys know tons of red tape to get through, even just to train with these on a Navy installation. So we're working through that and all the technologies that come with it. But as you all know, certainly some great capabilities out there, and it enhances our ability to do that job. You know, ADR and port damage repair are two of the biggest missions we focus on as we look towards, you know, potential conflicts in the future. So any technologies we can leverage in order to enhance our ability to do these missions is a big win. That's all I've got for you, and I'll stand by for any questions.
Thank you, Captain Green. That was a fantastic overview. Really interesting to see all the different activities, especially what I think you call the Phase Zero Theater Security Engagement Plan type activities all across the Pacific and other areas. Really, really interesting stuff. Can we ask if there's any questions from the audience for the Navy? Okay, hearing none for the Navy. Thank you again, Captain Green. Let me introduce Colonel Aaron Altweiss from the U.S. Air Force. Colonel Altweiss is currently the Chief of the Engineer Readiness Division and the Director of Civil Engineers in the Pentagon on the Air Staff. He is responsible for policy to ensure expeditionary readiness of Prime Beef and Red Horse Engineer Forces. He also produces policy for the fire and engineering services, explosive ordnance disposal, and emergency management capabilities across the Air Force. He oversees Air Force chemical, biological, radiological, and nuclear defense program as well. Colonel Altweiss entered the Air Force in June 1995, a distinguished graduate of the ROTC Corps at the University of Cincinnati. He's held multiple positions across the Air Force, to include 5 base civil engineer units. He commanded the 6th 28th Civil Engineer Squadron at Joint Base Charleston, where he also served as the president of the SAME Charleston Post. He's also served on Major Command Air Staff, Secretariat Combatant Command staffs, and is a Joint Qualified Officer. 5 different deployments, one time in command of the 577th Expeditionary Prime Beef Squadron in Southwest Asia, and his most previous assignment was commander of the 87th Civil Engineer Group at Joint Base McGuire-Dix Lakehurst in New Jersey. Colonel Altweiss, over to you, and let me know when you want to start the video, and I'll do that.
Great. Hey, good afternoon, everyone. Thanks, Bill, for the introduction. I know, like all of us, I'd rather do this in person, but I'm thankful for the opportunity to do it this way. And as a former post president, I'm thrilled to see so many people on the call in this virtual meeting. And Bill, it got me wondering if National is going to develop a streamer for connectedness during a national pandemic. And if they do, I'm pretty sure the post is already at the top. But before I really get going, I want to thank you all for what you're doing to keep things moving in our communities, and hope for health for you and your loved ones. So I'm Aaron Altweiss, been in the civil engineer business quite a while. In fact, yesterday I celebrated 25 years of commissioned service. It's nice to see some other Air Force engineers on the call today who I expect will hold me accountable. And of course, it's nice to see some other engineers on board with whom I've served. I'm going to call out Bill Haight and Ed Chamberlain specifically, and Randy Whitecotton on the Air Force side. So on behalf of Brigadier General John Allen, our Director of Civil Engineers, I'd like to tell you a little bit about what the Air Force engineers really do. I'm sure you're familiar with the design and construction part, or maybe even the environmental restoration part, but we are a lot of people doing great things for America. I'm not going to get into organizational charts or priorities or future states. I wanted to keep it simple. So to start, I'd like to show a short video, which is part of our We Are CE Civil Engineer series. So Bill, if we could get this going, thank you.
Everything that the United States Air Force does to project air power starts and ends with an airbase.
It's more than just facilities. It's more than just the buildings. It's all about the people that we support. It's not just a job.
I don't know if I'm going to be in 4 years, 10 years, 20 years, but doesn't matter how long I'm in, I just want to do the best I can. So when I look back, I'm like, I did what I could.
All right, thanks, Bill. Thanks for your note, Kathy, for posting that. We've got a couple of things on Twitter and Facebook and Instagram and this, that, and the other on the DVID site. So thanks for that. So, hey, I'll pull up my slides for everyone to see here. We'll see if we can get this going. I don't have a whole lot of words, mostly pictures. When it comes up, let's see. I got to see. I'm driving like Bill is here. Bill, can you let me know if you're seeing slides?
Yeah, you're good. Go ahead, Aaron.
Okay. You'll see I'm a graduate of the University of Cincinnati and Purdue. I did my staff college at the U.S. Marine Corps Command and Staff College at Quantico and my war college up in Carlisle Barracks at the U.S. Army War College. So why would I put a picture of airfield brooms on my first slide? Well, besides being really fun pieces of equipment to operate, it's also to highlight the key phrase in our mission, installations as weapon systems platforms. Our primary role as Air Force engineers is to ensure the installation, the place upon which we develop readiness, and the same place from which we deploy readiness is in a condition to meet combatant commander requirements. Quite simply, airplanes need runways, missiles need silos, and rockets need launch pads, and humans need places to work, and we attend to the physical and natural plant of the installations. If you were to ask us what we believe are truths, if you will, we would tell you that Air Force installations are power projection platforms, that asset management principles drive how we mitigate risk to installation health, that we measure our readiness first and foremost by the readiness of the weapon system we support. So for example, if an F-16 unit can't get off the ground because the runway is broken, their readiness is affected and therefore ours is affected as well. We would tell you that total force development at home enables ready airmen engineers to rapidly deploy and employ forces to adapt to full spectrum threats. That presenting agile prime beef and red horse capabilities supports the combatant commander's projection of air power. And finally, that installations are built by, maintained by, and are recovered by ready airmen engineers. So the Air Force engineer enterprise is about 55,000 people strong, almost 50-50 in civilians and military. We posture about 25,000 military in our units. The rest are on staffs in education or individual mobilization augmentees in the reserve component. We have almost 12,000 civilians working on our active duty bases and staffs, and a host more working at our reserve component installations. A lot of these pictures point to what might be considered public works. And while that's true, as I'm looking at my slide over here, it's not how I want you to take it. It is an important part of our mission, but doesn't explain why we have military in our units. Right now in the picture, you'll see military and civilians side by side who do electrical systems, power production, HVAC and refrigeration, pavement and construction equipment, water and fuel system maintenance, pest management, structural, industrial controls, including cybersecurity and engineering. And we have folks that do environmental compliance and restoration, housing and dormitory management, real property management and space allocations, project planning, programming, design, and construction. In our force, we have about 1,200 active duty officers, all of whom have an engineering or architecture degree. Our installations are normally presented as squadrons, which you look in the lower left-hand corner of the slide, with 3 flights doing the public works mission, although sometimes we'll see a civil engineer group with 2 or more civil engineer squadrons attached. Usually it flows from the wing to a mission support group to the civil engineer squadron, and then the flights. And that same organization is typically done in a deployed environment as well, except we'll just add an expeditionary word to the beginning. So instead of a civil engineer squadron, we'll have an expeditionary civil engineer squadron. On the upper left, you'll see our occupational badge. If I come up in the picture a little bit, you'll see it here. It's what we wear in our uniforms to let people know the engineers are in the house. And you'll see the tools the engineers with the wings to demonstrate our connection as engineers to those who support air and space. And there's another part of our installation mission that's done in the civil engineer squadron as well. And that is the protect piece I mentioned earlier, is we have folks that protect the installation and its assets. The squadron, the typical squadron, has 3 additional flights attached to it. And we do installation emergency management function with about 660 or almost 700 active duty military and civilians, which includes the chemical, biological, radiological, and nuclear defense training mission. We conduct explosive ordnance disposal missions for the installation and respond to military munitions found off base. We have just under 1,200 active duty EOD technicians and officers, and you may have encountered munitions on a construction site potentially. The military unit that responds is an EOD unit. If it's an Air Force unit, it's from a civil engineer squadron. And finally, we provide fire and emergency services to the installation with almost 12,000 total force military and civilian firefighters. And again, sometimes you'll see our fire trucks off base responding mutual aid to the local community. And as an example, I put their little badges on there too. So the EOD one is the one at the top, emergency management's the one on the right side, and of course the fire badge at the bottom. And you've noticed by now probably that our squadrons have both military and civilian members in them. And not only are installation power projection platforms, they're also readiness building platforms. So we practice our military practice the skills we need to gain proficiency at home in our formations. And we're integrated with our civilian team that helps train our young airmen and our officers and prepare them for deployments. And by organizing in this fashion, we're able to provide combatant commanders with highly skilled engineer expertise, because our Air Force engineers do the plumbing and electrical and HVAC all the time, and frankly, they're really good at it. And even more today with the National Defense Strategy, our teams have to focus on being able to do our most important mission, which is recover the airbase. No installation is a sanctuary, either at home or abroad, so this recovery mission is becoming more important here at home even. When we deploy, we present our capabilities one of 2 ways, either a prime beef or red horse. The red horse capability is probably more aligned to the CVs or a combat heavy unit, and that they do the majority of their mission in the horizontal area, but certainly do larger vertical work as well. And they are easily spotted in their natural habitat with the red hats, or in the case on this slide deck, with the red borders. The prime beef capability is more akin to vertical construction and base operating support. Now, to be clear, they all wear the same occupational badge and have the same occupational specialty codes, and they'll flow back and forth between prime beef and red horse as they get assigned to different units across the Air Force. But our red horse units don't provide that public works capability at an installation. Their job is to be more expeditionary in a quicker manner with a heavier capability. And nor do Air Force engineers provide combat engineering in the doctrinal sense. We love, however, to operate in that combat environment. The pictures in front of you that we're seeing on the slide are airmen doing the same mission sets, but in a contingency environment. They're designing, building, operating, maintaining, repairing, protecting, and closing air bases as needed. The key distinguisher is that their main mission focuses to their ability to rapidly recover an air base after an attack, be it kinetic, natural, or cyber. They are, I'm a little biased here, but they're a force to be reckoned with. Our Afghanistan experience showed we can self-maneuver in the battle space. We provide key enabling capabilities to the warfighter, and while this might generate some discussion in the chat boxes, our combat warriors knew they were in good hands when the prime beef patch showed up to fix their fob. And now today, as we develop our engineers to operate in a more agile construct, we'll be there as key enablers to air, space, and cyberspace missions as we get into even smaller, more robust, and dynamically employed force constructs. If anyone's interested as of now, there are no plans to have installation engineers as part of the U.S. Space Force. Those Space Force bases will be supported by U.S. Air Force Airmen. That may have sparked some interest, but I'll tell you it's still developing. And in some news, General Allen will be departing the district at the end of the month and going to Joint Base San Antonio, where he'll take command of the Air Force Civil Engineer Center. And replacing him here in D.C. will be Brigadier General Select Bill Kale, who's coming over from the Hill as the Air Force's Senate liaison. All right, so I told you I'd be short, I told you I'd be sweet, and that's about it. I'll let you know the wave tops of what we do for installations and our deployed missions. And as I wrap it up, though, I'd like you to think of the Air Force engineers in this way. We're not a public works organization. We're a combat support formation that happens to do public works. So, Bill, hopefully that got us some time back. Of course, I'm ready for some questions. I didn't get a lot of details. Happy to do that, though, in the chat forum or on video. Over.
Very good. Thank you, Aaron. It's an excellent overview of the Prime Beef, Red Horse, and all the other Air Force elements. Great team. And I'll tell a very quick story. When I was a C7 multinational Corps of Iraq back in 2006, if you needed something done well, you called on the Air Force to go do it. If you needed something done where it had to be done well, and the Army go do it. Just a little joint joke there. So thank you for that. Any questions for the Air Force? Okay, hearing none, I'm going to introduce our next speaker.
Yeah, I did see a question, Bill, sorry, this is Aaron on the chat about using solar lighting that's deployable. The Air Force Civil Engineer Center is working on that. Don't have anything to go out there right now. There's some standards that have to be worked through, but that certainly makes sense as we're moving through the rapidly deployable airfield lighting kits. Over.
Great question. Any other questions for Colonel Otweiss from the Air Force? Okay, seeing and hearing none, let me introduce, please, our next guest speaker, who is from the U.S. Coast Guard, Captain Pat Dugan. Pat assumed duties as the Chief of the Coast Guard's Civil Engineer Program in September of 2018. He oversees the Coast Guard's real property portfolio, facility management, and facility investment. His most recent prior assignment was as the Commanding Officer of the Facilities Design and Construction Center in Norfolk, the Coast Guard's only MILCON level construction command. Captain Dugan was commissioned from the U.S. Coast Guard Academy in 1993 with a Bachelor of Science degrees with honors in marine science. He holds a Master of Science degree in ocean engineering from the University of New Hampshire. And he's a registered professional engineer from the state of Ohio. He's also earned his DHS Level 3 Project Program Management certification, and he is a certified PMP as well. So, Pat, over to you.
All right, thank you, Bill, and thank you for having us all on here. This is truly a pleasure to talk to the SAME, NOVA, and DC posts. I will do a shout out to my former post, which is a bit of a rival. I was the past president of Hampton Roads, so glad you could have me here. I'm not sure how I drive on this, so Bill, I'm just going to ask you to drive. All right. And I'm not hearing you, Bill. Can you hear me?
Yeah, let me unmute and I will pull your slides up. Just give me 2 seconds.
Okay. As you bring them up, I'll just go ahead and start a couple things. And I'll contrast with Colonel Otweiss's presentation there. He talked about being much more than a public works organization. I will tell you that I am primarily a public works organization. Up until just a little bit ago, I would have told you we don't have any deployable civil engineering at all. We're changing that a bit. We are very much inwardly focused. Next slide. All right, that's what we're going to talk about, and that little new at the bottom is kind of the teaser for a piece coming later. Next slide. One back. There we go. Those are kind of pictures of things we have in our portfolio. We all like to show pictures off of what we do. And Coast Guard's a little bit small. I think I've been personally to most of these sites. There's kind of an example of things we have rolling around. The ATON are actually a lot of fun. Lower left picture. Anybody who's been who's a boater has been out and seen fixed aids navigation in the water. That's actually my largest portfolio of structures in the Coast Guard. All those towers, east, west, Gulf, and Great Lakes coasts, you see those out there. All right, next slide. All right, we do manage an amazing portfolio. We are the largest real property owner in DHS with about just over 41,000 total assets. Again, those towers are a lot. You see it there, the third piece there on the right, the fixed ATON. 20,000 of my 41,000 things are towers in the middle of nowhere. All right, next slide, please. All right, these next two slides are the crux of what we do and also the crux of my problem statement. So this slide, arranged by Coast Guard District, shows where we have Coast Guard civil engineers. They're divided into both base facility engineers, which are the stars, the red stars, and we have regional civil engineering execution, which are the blue dots. And I'm not sure about the DoD counterparts, but for us, if you're a base civil engineer, you are part of the base organization itself. It's not a separate group attending to the base. The facility engineer is as much part of the base construct as is the comptroller or anyone else. So, but my issue is that's where I have people. You notice I have the Great Lakes circled here. And if Bill will, actually, hold on before we go next slide. The difference is here, the red stars are, again, base civil engineering, base public works type of deal. And the blue dots are more regional execution. So with that in mind, go to the next slide. I zeroed in on the Great Lakes. If you recall from the previous slide, Cleveland was the only place in the Great Lakes where I had civil engineers. Yet, here is my force laydown in the Great Lakes simply for boat stations, not even counting our air stations. You'll notice that, well, I don't have civil engineers at most of the places I have units. All right. And by the way, these boat stations I show here, like at the thumb of Michigan, you see Harbor Beach and Saginaw River. Those are typically E7, E8 commands, and they have about 40 to 50 personnel each. And like I said, not a facility engineer. They do have boat engineers, and we require a lot of those folks. All right, moving to 7, please. Next slide. All right, so what do we do as facility engineers? This is from the base level. These are the base level folks. They do everything Public Works normally does. I've been there myself. It's a lot of fun. It's a challenge a day. And if you haven't had a facility engineer billet, I urge you to go get one because it's a challenge every single day. Next slide. We keep going. The facility engineer is every bit of property, every bit of maintenance, everything you see on the base. A lot of fun. All right, let's keep going here because I want to have some time at the end for a little bit of discussion. All right, next slide, please. The regional facility engineer. This is also charged to the base. We ask them to coordinate with all those units around them that don't have facility engineers to walk them through not just assessments, but then how to get things done. Our boat operators simply are not plugged into the civil engineering program, and they refer to our larger base engineers to help out. So if you're if our folks are at base Alameda, California, San Francisco Bay Area, they're helping out units up and down the California coast, not just the base itself. All right, next slide. All right, now I turn to my regional units. My regional units do depot level maintenance, re-roofings, new docks, new building envelope, that kind of stuff. Whereas the bases are mainly the operational level, everyday public works. And at the regional level, we do have facility asset managers, and we've really worked on codifying what they do, ensuring we have a standard process for evaluation, and then evaluation documentation, and ensuring we stay ahead of facility needs for all those little units that you just saw on that Michigan slide. All right, next slide, please. All right, standardized facility assessments. We've spent a good bit of time working through standardization for our units to make sure that my folks in Miami, my folks in California, and my folks in Juneau, Alaska are all doing the same thing and treat our units the same. It's been quite a step. our next steps moving through, working with the Army Corps, bringing in Builder into our software as predictive software. We do perform predictive software, but we're moving towards better. All right, next slide. Contingency response. Hurricanes hit. Hopefully not this year, but hurricanes hit, et cetera, et cetera. And both the base and the more regional engineers form our disaster assistance teams, DAT, and they converge upon the area hit to assess. We don't do a lot of the physical, let's go make it better right away. It's the assess and then figure out what our next step is. Is it a localized contract? Is it a regional contract? How do we then go in and deal with the damage that we have? Next slide. And there we go. This is just a listing of the different things the damage assessment teams do, and they deploy out for every emergency that we have. Again, made up of groups from all areas. If we have a hurricane hitting Florida, our DATs are coming from New England, from California, from wherever. All right, next slide. I'm going to spend a little more time on this very last slide here. Very new to the Coast Guard, the Housing Assistance Team. I mentioned at the beginning we weren't deployable until just recently. We are standing up 3 housing assistance teams this year. My housing, much like my stations, I have some in bases. I mentioned Kodiak there on the slide, 424 houses in Kodiak, 05 facility engineer. But we also have stations throughout the Coast Guard, and I mentioned one in California, 5 houses. It's got an E5 collateral duty taking care of them. Well, to better manage our housing, we're standing up these 3 regional teams, and the idea is for them to put housing maintenance on even keel throughout all those small housing areas. So we're just getting them up. The first billets are just arriving now, and the whole goal is to be deployable. Hurricane hits, they go out and they're carpenters, electricians, they're hands-on getting the houses fixed. So that's our first foray into that arena. Last thing I did not mention, my entire organization, civil engineer in the Coast Guard. As an 06, I am the chief civil engineer of the Coast Guard. And we have about 800 people total throughout all of those civil engineering billets in our nation. With that, I'll take questions.
Thank you, Pat. That's really fascinating, especially this last piece. Let me start with a quick question. The carpenters and electricians and other trades personnel that you're going to have in the Coast Guard, will they go through the joint training for those specialties at Fort Leonard Wood, as many of the other services do, or do you have your own training program for them?
I do not have that's a great question. I do not have my own training program, and we are actually using this first group to evaluate a few different training options that we have. We've never done this. So we actually turned to the Seabees first on how the Seabees train their folks. And we're evaluating everything from Seabees to even Home Depot and those types of courses. So I will say this is very much a experimental as we first go, but I appreciate the Navy's help with getting us up on the right foot. Over.
Oh, very good. Thank you. Any other questions for Pat from the Coast Guard? I see one. Let's see. I see a shout out to the Seabees from Luke. Okay. Okay.
Absolutely. And I'll just go ahead and give a shout out to Colonel Outwise as well. He mentioned going to University of Cincinnati. Go Bearcats.
Yeah, very good.
Are you a Bearcat?
No, I grew up near Dayton though.
Oh, okay. All right. Buckeye fan though, clearly.
Oh yeah. Okay. And I'll take any other questions.
Any other engineering questions? If not, thank you, Pat. And we're going to move on now to the Public Health Service. Let me introduce Captain Nelson Mix, who is in the Public Health Service, but he's currently serving as an environmental engineer with the EPA's Water Security Division in the Office of Groundwater and Drinking Water. Nelson began his federal career in 1991 with the Indian Health Service by designing and constructing water and wastewater systems for Indian tribes. He's been with the EPA since '97, where he's worked in a variety of programs related to emergency response, hazardous materials, and water security. Nelson's currently managing the advanced metering infrastructure, physical security monitoring, and customer complaint surveillance components within the water quality surveillance and response system program, which is designed to help water utilities improve their ability to detect and respond to drinking water contamination incidents. Nelson's a member of the American Waterworks Association. He's a PE and a fellow in SAME. His education started with Brigham Young in '92, MS in Civil Engineering from the University of New Mexico in '96. Nelson, over to you.
Thanks, and thanks for having me. Can everyone hear me okay, I hope?
Yep, we can hear you.
Great. And hopefully everyone can see my screen. Is that the case?
Let me stop sharing and make you the sharer or the presenter. And that should be happening here in just a second.
But yes, we can see your video very well. Thanks.
Okay, you should be able to pull up your slides now, Nelson. There we go. We got them.
Okay, let's see. From beginning. Great. Don't worry about the phone ringing. It's a telemarketer. Thanks for having me. And Bill, congratulations on recently becoming a fellow. I was the DC Post president around the time Mary Anderson was president of the Northern Virginia Post. And so it's an honor to be here. I'm going to make a donation to the scholarship fund and for the Nova Post. And I hope everyone that's online is generous as well, if you can be. And I hope everyone is safe. A lot of people right now probably, if you haven't heard of the Public Health Service, by now you will know who we are by the end of the presentation. I think the blue uniform has paid some dividends recently for our service. We switched to it about 5 years ago, and currently this is our uniform of the day. Presentation overview, a little history, death by PowerPoint. It's going to fly a lot of animation in at you. Where we work, what we do, and then I'll wrap it up. So 1798, John Adams created a Marine hospital service. It was the forerunner of the Public Health Service. And we had our first Surgeon General in 1871. The position became effective in '73. And in '89, we had a commissioned corps in the Public Health Service. So we're kind of an old service. Currently, we're 6,500 officers, no enlisted corps. We are comprised of doctors, nurses, dentists, therapists, veterinarians, a lot of pharmacists, over 1,000. We have more pharmacists than all of the other services combined. We have an environmental health officer category and an engineering category that boasts just over 400 officers, ranging from 02 to 07. The chief engineer is Rear Admiral Ed Deezer. The Marine Hospital Service was renamed to the Public Health Service in 1912, and a year later, the Public Health Service had its first sanitary engineer, and we had the first drinking water standards a year later. So really about 100 years ago, there was a lot going on. I think it's a fascinating period of history for public health. We started chlorinating drinking water in the early 1900s. Disease theory evolved from the 1880s. And, you know, we know the society just went through its centennial, you know, for 1920. And there was the Spanish flu, right? In 1918, World War I was going on. The Public Health Service helped out. Industrial hygiene, malaria control, cholera, these were all the diseases of the day that we were fighting. And 1930 Parker Act assimilated us into regular corps. I'm not going to get into the world wars. 1941, World War II, the Communicable Disease Center, the forerunner of the Centers for Disease and Control, was created in '46. 48, there was an incident in Denora, Pennsylvania. You know, it used to be just doctors ran the commissioned corps. The engineer category was the second category to be commissioned, followed by other categories, is my understanding. The mission in environmental health continued to grow in the 40s and the 50s, and even into the 60s. 1955, the Indian Health Service was created to specifically provide healthcare for Native Americans, as well as sanitation facilities and construction. And I'll get into that in just a minute. But that's where a lot of our officers are assigned, is to the Indian Health Service. EPA is celebrating its 50th anniversary this year. NIOSH was formed in the 1970s to make recommendations about work-related injury and illness. And in 1985, ATSDR was created or formed to help with minimize health risk from exposures to hazardous substances. And we have officers that work in all of these programs. And, you know, I didn't talk about other disasters and outbreaks. I'm going to skip ahead to more recent ones that have been really more in my career. Some of these I've responded to and our officers have. But the Public Health Service March has a line in it, and it says, "In the silent war against disease, no truce is ever seen. We serve on the land and the sea for humanity," the Public Health Service team. I'm glad I'm not really singing it for you. But, you know, the point that I want to make is I think the Public Health Service is really at war right now. And our enemy that we fight, we don't see. It's invisible. It's about 0.3 microns. It's COVID-19. You know, a coffee filter is about 5 microns for filtration. A human hair is, you know, anywhere between 50 to 75 microns. And so we're in a different dynamic. I'll get into a little bit more about what we do when we deploy and we fight disease. You can see on the slide some pictures of deployments, and they were covered on the previous slide. Ebola was a big deal for our service not too long ago. That's when we switched to the blue uniform, and it was the right call for us. We recently celebrated our centennial anniversary, and we listed some of the milestones or accomplishments that we, you know, want to take credit for related to engineering. And you can see those. Safe drinking water. It's a great mission. I'm proud to be a part of it. Safer foods, motor vehicle safety, controlling infectious disease with clean water, and worker safety. So how do we go about accomplishing that? We have engineers that are scattered across the country. I mentioned we're just under 400. A bulk of them are in the Southwest and the Great Plains area with the Indian Health Service. We have a lot at the Food and Drug Administration, the pushpins in red, and then the EPA. And those are our three predominant our assignments for our officers. This slide shows the different types of disciplines of engineers that we have and where they work. Mostly civil environmental engineers doing water, wastewater sanitation for the Indian Health Service, environmental engineering, chemical engineers. We have a lot of biomedical engineers, and those are at the Food and Drug Administration. And we'll get specifically into what some of their missions are with some pictures in the next few slides. And we did have a nuclear engineer, he just retired. But as you can see, there's a good cross-section of disciplines. CDC, research and health-related controls, you know, for the engineering programs at CDC. Not a lot of engineers at the CDC, maybe 10 to 20-ish, if that. NIOSH, same type of thing, a lot of lab work as well as field investigatory work, and there are some pictures of some of the work that they do. ATSDR helps support the EPA Superfund program for risk assessment. We have a few engineers that work there as well as other officers. National Institutes of Health, the campus in Bethesda. We have engineers working there with state-of-the-art facilities and equipment to help support the scientists and the healthcare that goes on at NIH. The Food and Drug Administration has a lot going on as far as medical devices, as well as 3D printing, inspections of pharmaceuticals, imports, and there's a lot of opportunity and career paths that engineers can take at the FDA. I'm at the EPA. I know it the best. I started my career at EPA in the Superfund program in the Midwest as a federal on-scene coordinator. My current job is to, keep the water safe. It's easier to explain to my kids what that is versus, say, continuity of operations for government or, training and support to, hazardous materials responders. But we also have engineers assigned through the EPA in the Pacific Trust territories, helping with the water programs there. And these are some photos of me earlier in my career. It makes me think of Mike Rowe in Dirtiest Jobs. If you guys want to have some fun right now, I challenge you to post in the chat some of the dirtiest jobs you've ever had. I thought growing up on a dairy farm would take the case, but I think this one in the bottom center is one of the times I decided to suit up and get the job done. Lastly, well, two more. National Park Service had our first engineer and environmental consultant work there in 1921, and they helped manage construction programs and projects at the Park Service, as well as doing assessments for their water and wastewater facilities. And then lastly, the Indian Health Service. It's where I started my career in the early 90s with the Public Health Service, actually as a summer student, and I'll talk about that in just a minute when we conclude. But it was great work. The Indian Health Service, parts of our country are like a third world country on some of the reservations. We've been hearing a lot about the Navajo right now with COVID-19. There are some desolate areas. There is some poor hygiene and sanitation that has caused a higher incident of the disease there. And there's just a lot of great work that goes on. It's straight civil engineering. It's pipes and dirt, and there's a lot of history, and it's probably the largest dollar program where our engineers are working, except for maybe the FDA. The EPA where I work, it's grant programs to the states. Just some more photographs from Indian Health Service, and a lot of working with the communities, and it's great work early in a career because it helps you work remotely and in austere conditions to prepare you later on for other assignments. So in summary, consulting, designing, constructing, testing, evaluating, analyzing, training, management, there's a lot that our officers do. And my final slide is we have an opportunity right now. If you know of any young college students that are interested in joining the Public Health Service as an engineer, there is a commissioned officer student training extern program that the Public Health Service has. I did it twice, my junior and senior year. I worked 1 year in Alabama, 1 year in Maine, worked for an engineer. I was commissioned as an O1 temporarily for a maximum of 120 days. I was able to pick up 240 days towards my retirement. After I graduated with my engineering degree, I started working extended active duty with the Indian Health Service. And so that time not only counted towards retirement, but my base pay entry date. And, the training, the way that it works with us, we have an officer basic course. I think one of the first pieces of equipment that were issued is, this book right here. It's called Plagues in Politics. It's been a great career for me. And if you know of anyone who is interested in this kind of work, I would encourage them to take advantage of this window and apply. So that concludes my brief, pending any questions. Thank you.
Captain Mix, thank you very much for that. That's a really interesting history and overview of the U.S. Public Health Service, and you really pointed out the fact that you really are spread across a lot of different agencies in the U.S. government. The one that you're with now currently, EPA, is just one. and really great suggestion there for getting young engineers up and coming into that program. I think a couple of us are associated with some universities. We'll definitely share that information with them. We did have one question already in the chat. The question is, how are the engineer positions funded within the Public Health Service?
Yeah, that's a great question. So we have a lot of officers assigned to different programs, and the program funds the position. So my position is paid for by the EPA. The Park Service pays for their positions, the Indian Health Service, etc. There is a memorandum of agreement in place between the Department of Health and Human Services and the optive where the officer is assigned. And there's a funds out transfer using an interagency agreement to fund the salaries and other costs associated with officers. And so that's it in a nutshell. The agency has to have the position available to hire.
Excuse me, very good. Any other questions for the Public Health Service? Okay, thank you, Captain Mix. Appreciate it. That's really, really interesting. At this time, I'm going to open it up, and I'm going to ask some of our panelists had to depart the session, but I'm going to ask them all to turn the cameras on if they're still here, and we'll open it up to general questions across the Purple Force, the Joint Force, for our engineers. And one other, let me just plug something I should have mentioned earlier. We are going to give away a free raffle here at the end of the Q&A. To those who are still hanging in there with this 2-hour session. So if you're tempted to leave a little early, there's a free lunch raffle if you hang in there a little bit longer. So let me open it up, please, to questions either by chat or by audio for our joint engineers who gave us our presentations today. You got one question in the chat. We got a thank you to the speakers. Okay, thanks, Al. I have a question, and this goes out to really any of the panelists. I was prompted to it by what I saw in the Navy's presentation, which is the building of schools and clinics and things of that sort in overseas locations. I presume that's part of a Phase 0 theater security engagement plan activities across combatant commands. Let me ask if any of the services are doing anything on an interagency level, like with USAID and other development agencies doing that kind of work overseas.
I'll jump on it and just say that, yeah, definitely. You know, our work, when we do those types of projects, they're always coordinated with the State Department and then sometimes USAID or other organizations. Great example, you know, one of the exercises that we've participated in a lot, you know, the CB's Pacific Partnership. If you're not familiar with that, again, that was born out of the tsunamis in 2004, but it's an annual or biannual, one of the two, exercise that and they go all over the Pacific. They'll activate one of the hospital ships and send her out to comfort, you know, so you have doctors on board, they'll pull into port, but we send engineers out well ahead of that to do a construction effort. So by the time the big, you know, the group rolls in for Pacific Partnership, there's a school or a clinic or something that's been built. They come in, they provide some medical assistance. So it's more than just the engineering aspect of it. But again, it's that building the relationships, and there's often other government agencies involved in that. So.
Yeah, and
another question?
I was just going to add, the Public Health Service, I believe, has an officer or two assigned to USAID, and the Centers for Disease Control has officers assigned on pretty much probably every continent.
Very good, very good. Any other questions for our engineer service representatives? Okay, I'll pose one more. We see across the Joint Force, in some cases, in some commodity areas, some consolidation of functions. One that we've seen more and more consolidation is in the area of logistics with the Defense Logistics Agency. We've now seen some consolidation of some functions in the health services with Defense Health Agency. I'm just curious, is there any thinking or talking about a consolidation of engineering with the three services or the multiple services and engineering capabilities? Any thoughts or rumblings about that?
Well, this is Aaron. I don't think I'm going to step on that landmine right there. I think we, each of us like to be different, right? And when the joint force calls us together in the deployed environment or here at home, then we come together and we do pretty amazing things no matter what uniform we wear. I've not heard of any type of, mashing together your MCOMs or your NAVFAC regions or your an Air Force, Installation Mission Support Center into a DoD type of thing at this point.
Okay, very good. Thank you. It was a minor point of discussion about 10 years ago when I was on the Joint Staff. So that's why I'm asking if that is still alive.
I'll pile on that too, though. I think there's always a healthy tension between effectiveness and efficiency, and I think to go that kind of joint, you would lose some of the effectiveness that we need to be able to just jump on immediately, and each of the services would lose a little bit there. So I think, as people look at budgets and the guys with the green eye shade sit back and try and find efficiencies, I'm sure it'll come up again, like you mentioned, it's come up in the recent past. But I think there will be always a resistance from the services to lose that effectiveness that they need.
Thank you, Captain Green. And let me just say that with the all the presentations we saw today, very clearly, very unique and focused capabilities and capacity to support the services that you all serve in. And what a great overall joint force we have of engineers in our nation, ranging from the combat end to the home-based support end and everything in between. So I want to thank all of you for taking the time. I know it was a long 2-hour session and everyone hung in there, but a huge amount of information. All this information will be posted on the website for NOVA and for JECO. So please watch for that. I am going to take charge of the screen here for a second. I want to just finalize by lastly, again, thanking our speakers and for all their time, and to remind everyone of our next event, which is the 9th of July. And then we have a raffle, free lunch raffle, and it's only eligible to those 39 who are left online. So Julie or Jenny, whoever's running that, you want to jump in and tell us who the winner is?
I think, what number did we pick, Ed?
Stand by. I'm entering the random number generator at this time for the free virtual lunch. So the winner is, hold on, regenerating. Winner is caller number 37, which process of elimination is Stan Murphy.
Stan Murphy. All right, Stan Murphy.
Congratulations. You get a free virtual lunch. Is that correct, Julie? Are we raffling a free?
No, a real lunch. We're doing the next real lunch.
Oh, that's real lunch. My bad. Congratulations, Stan Murphy.
All right, so Stan, I don't know if you hear us, but you got a free lunch for the next attendance at a NOVA event.
I hear you. I'm good.
Finally, let me close with, again, my thanks to everyone who put efforts into putting this together, most significantly our panel members. And let me also throw out a thank you, in addition to the folks who have volunteered and donated to the scholarship fund. We also have the firms that you see on the slide here were also specific sponsors for today's event. They added a little extra to the pot for us to host this event near the Pentagon, so we could do it physically. It was going to cost a lot more there, but when we went virtual, they all graciously agreed to leave their extra donation in the pot for our scholarship. So many thanks to all of these firms, sponsor firms, for doing that. Again, to our speakers and panelists, thank you very much. To all of you in SAME and JECO. And the NOVA Post, thank you for your time today. I hope you enjoyed the seminar. webinar, and we will look forward to seeing you again on the 9th of July for our next event. Thank you, everyone.